This question sets the stage. I'm dealing with a semi-supervised learning problem using scikit-learn's label propagation. I have a dataset, 1000 samples total, where I've already labeled 100 and need to predict labels for the other 900. The core focus is understanding how the kernel parameter affects the predictions. I have 100 samples that are already labeled. This is my starting point for label propagation. I'm working with a total of 1000 data points, a relatively substantial dataset. This is about efficiency. Different kernels, like RBF and KNN, have different computational costs. Using one over the other can have big effects on runtime, especially with larger datasets like the one I'm handling. The goal is to assign labels to these remaining 900 data points based on the information from the 100 labeled samples. The gamma parameter is specific to the RBF radial basis function kernel. I adjust it to change how wide or narrow the Gaussian function used in the RBF kernel is. It's like deciding how far a point's influence reaches. The n_neighbors parameter directly dictates how many neighbors the KNN nearest neighbors kernel considers. It is a key component of that specific kernel. This statement is incorrect. I can't say for sure that RBF is always better. It depends on the dataset. We're exploring how the kernel choice affects the label propagation algorithm in scikit-learn. The algorithm's goal is to predict labels for unlabeled data points using labeled examples. We'll focus on two kernels, RBF radial basis function and KNN nearest neighbors. I have 100 data points with known labels. These are the examples the algorithm uses to learn. I have another 900 data points whose labels I want to predict. That's where the label propagation algorithm will put in the hard work for me. In total, my dataset has 1000 samples, 100 labeled and 900 unlabeled. This is the complete data set to work with. The question will test my understanding of how different kernel options affect the performance of label propagation. I need to think carefully about the RBF and KNN kernels and their respective parameters. It will be interesting. I'm exploring how different parameters in scikit-learn's label propagation algorithm affect its performance, specifically focusing on the kernel parameter. I'll look at how the choice of kernel, RBF, or KNN, and its associated parameters influence the results. This is a multiple-choice question about the label propagation algorithm's kernel parameter and its impact on prediction accuracy and computational cost. I need to evaluate each statement carefully to determine if it is true or false. I'm working with a dataset containing 1000 samples, 100 are labeled, and 900 are unlabeled. I will use label propagation, a semi-supervised learning technique, to predict labels for the 900 unlabeled samples. I'm deciding which kernel to use and understanding what that choice means. The gamma parameter is specific to the RBF kernel. It controls the width of the Gaussian function used in the radial basis function kernel. A larger gamma value creates a narrower Gaussian, while a smaller gamma value creates a wider one. This impacts how similar nearby data points need to be. The choice between the RBF and KNN kernels significantly influences the algorithm's computational speed. The RBF kernel, which involves more complex calculations, tends to be slower, especially with larger datasets, compared to the computationally simpler KNN kernel. Think of it like this: calculating distances to all points, RBF, is slower than just checking your nearest neighbors, KNN. I must choose between two kernels, RBF radial basis function, and KNN nearest neighbors. Each kernel uses a different approach to measure similarity between data points. My choice will affect prediction accuracy and computational efficiency. I'm analyzing the parameters of scikit-learn's label propagation algorithm, a machine learning method for semi-supervised learning. This means we use a small amount of labeled data to predict the labels of a much larger amount of unlabeled data. This analysis focuses specifically on understanding how the kernel parameter impacts the algorithm. This question tests your knowledge of the kernel parameter in the label propagation algorithm. We're looking for true statements about how this parameter affects the algorithm's behavior and performance. We're given 4 statements, A, B, C, D, and must determine which are true or false. This statement is true. The gamma parameter is specific to the RBF radial basis function, kernel. It controls the width, or influence, of the Gaussian function used to measure similarity between data points. A larger gamma value leads to a narrower Gaussian, while a smaller gamma leads to a wider Gaussian. This statement is also true. Different kernels have different computational costs. The RBF kernel, because of its Gaussian function calculations, can be more computationally expensive than the KNN, K nearest neighbors, kernel, especially when dealing with many data points. The KNN kernel is generally faster, as it only looks at the nearest neighbors. This statement is false. While the _n_neighbors parameter directly controls the number of neighbors considered in the KNN kernel, it plays an indirect role in the RBF kernel's behavior. The width of the RBF kernel influences the effective neighborhood size, somewhat similarly to _n_neighbors. This statement is false. There is no such guarantee. The best performing kernel depends entirely on the specific dataset and its properties. Sometimes, RBF works better, other times, KNN is superior. I'm working with a dataset containing 1,000 samples, data points. Out of those 1,000 samples, 100 have known labels. This is our labeled data. The remaining 900 samples have unknown labels. We'll use semi-supervised learning to predict their labels. I am using the label propagation algorithm to predict the labels of the unlabeled data. The final goal is to get accurate prediction results for those 900 unlabeled samples using the label propagation algorithm with an appropriate kernel and parameters. I'll explain how you choose between different kernels for the label propagation algorithm. The kernel defines how you measure similarity between data points. Think of it like choosing a lens for your data. It can make a big difference in your results. This uses a radial basis function, specifically a Gaussian function, to measure similarity. It's like measuring how close 2 points are based on a bell-shaped curve. The wider the bell curve, the more similar distant points are considered. I use the K nearest neighbors approach. This means I look at the K closest neighbors to determine similarity. It's a direct and intuitive way to define neighborhoods. This parameter controls the width of the Gaussian function in the RBF kernel. A larger gamma makes the curve narrower, meaning only points very close together are considered similar. A smaller gamma widens it. This tells the algorithm how many neighbors to consider when using the KNN kernel. More neighbors mean more points contribute to the similarity calculation. I'll compare how much computing power each kernel needs. Generally, the RBF kernel is more computationally expensive than the KNN kernel, especially when dealing with large datasets. Think about how many calculations are needed to compute the Gaussian for each pair compared to finding K nearest neighbors. RBF generally needs more computation. KNN generally needs less computation. This is the title. I'm focusing on how different kernel choices affect the label propagation algorithm, a machine learning technique used for semi-supervised learning. This is the core question. We need to evaluate 4 statements about how the kernel parameter influences a machine learning algorithm's performance. This statement is true. The gamma parameter is specifically for the RBF radial basis function, kernel. It controls the width of the Gaussian function, a bell-shaped curve, that the algorithm uses to measure similarity between data points. A higher gamma means a narrower curve, focusing on only very close neighbors. This is also true. The RBF kernel tends to be more computationally intensive than the KNN, K nearest neighbors, kernel, especially with a large dataset. This is because the RBF kernel calculates distances between each data point and every other point, while KNN only calculates distances to the closest neighbors. This statement is false. While it's most directly relevant to KNN, affecting the number of neighbors considered for each point, gamma, in RBF, also implicitly controls neighborhood size. It's like a similar control but with a different mathematical representation. This is false. There's no guaranteed winner. The best kernel depends entirely on the specific dataset. I'm analyzing how different parameters in scikit-learn's LabelPropagation algorithm affect its performance. Specifically, I'm focusing on the kernel parameter and its interaction with GAMMA and NNEIGHBORS. This is crucial for understanding how to choose the best settings for different datasets. This question tests your understanding of the LabelPropagation algorithm's parameters, especially the impact of the kernel choice on the prediction accuracy. You need to evaluate each statement given about the kernel carefully. This statement is correct. The GAMMA parameter is specifically used with the radial basis function, RBF, kernel. It determines the width of the Gaussian function. A larger GAMMA means a narrower Gaussian, making the model more sensitive to local variations. Absolutely. The computational cost varies significantly depending on the kernel selected. The RBF kernel is generally more computationally expensive than the k-nearest neighbors, KNN, kernel, especially with large datasets. This is because the RBF kernel calculates distances between all data points, while the KNN kernel only considers the nearest neighbors. I have a dataset with 1,000 samples, 100 of them are labeled, and the other 900 are unlabeled. The LabelPropagation algorithm will use the labeled data to predict labels for the unlabeled data, and the kernel choice will influence how this prediction happens. I'll be using scikit-learn's implementation of the LabelPropagation algorithm, a powerful tool for semi-supervised learning. This algorithm cleverly leverages both labeled and unlabeled data points to build a robust prediction model. The kernel parameter allows me to choose between two different kernel functions, RBF, which uses a radial basis function, a Gaussian function, and KNN, which uses the k-nearest neighbors approach. This choice critically impacts how the algorithm determines the similarity between data points and, ultimately, the predictions. The NNEIGHBORS parameter is used only with the KNN kernel. It specifies the number of nearest neighbors to consider when determining the similarity between data points. A higher NNEIGHBORS value typically leads to smoother decision boundaries but might oversmooth the predictions.